We talk all the time about how powerful AI models are, but they're also holding on to a pretty dangerous secret. All that private data they were trained on, well, it's still in there. And there's this really sophisticated threat called a model inversion attack that can literally trick an AI into spilling those secrets. So let's break down exactly how this works. But first, a quick heads up. What we're doing here is a high-level overview. If you want the really deep technical dive, you should definitely check out the full tutorial from Virtualization Options LLC. Okay, with that said, let's get right into it. So here's the fundamental problem. When we train an AI on sensitive stuff, I'm talking medical records, financial data, even our own faces, that information doesn't just, vanish. It gets baked into the model's DNA. And a determined attacker can pretty much pick the lock on that model and pull the original private data right back out. And that lock-picking trick? It's got a name, a model inversion attack. You can think of it as a kind of reverse engineering. So instead of giving the AI an input to get a prediction, the attacker works backwards. They send carefully crafted inputs, analyze the model's responses, and use them to piece together the private data it was built on. It's kind of like figuring out a secret recipe just by tasting the finished cake. And believe me, this isn't just some theoretical lab experiment. Let's look at a real-world threat. Researchers have actually attacked facial recognition systems, the kind used to unlock your phone, and have been able to reconstruct recognizable faces of people from the training data. Yeah, your biometric password, your face, could literally be stolen. The stakes get even higher when we talk about healthcare. Imagine an AI trained to diagnose diseases. An attacker could use a model inversion attack to expose sensitive patient data, revealing someone's specific medical condition or their treatment history. This is a massive privacy disaster, a direct violation of HIPAA, and it just shatters the trust we have in these systems. And it doesn't stop there either. Financial models, the ones that decide if you get a loan, they're vulnerable too. By carefully probing these AIs, an attacker could start to figure out sensitive things like credit score ranges, income levels, and other personal financial details that were used to train the model. Let's be crystal clear about this. The fallout from these attacks is huge. We're talking about direct privacy breaches that could violate major laws like GDPR and HIPAA. This kind of vulnerability completely erodes our trust in AI. For companies, it creates massive legal and financial risks. And it could even scare people away from using AI in really important fields where it could do a lot of good. So, how in the world do we fight back against this? Well, we bring in the good guys, AI penetration testers, or pen testers. These are the ethical hackers who learn to think exactly like an attacker. They've got a whole playbook for hunting down these hidden secrets before the bad guys find them. And this quote right here, it perfectly captures their mindset. For an AI pen tester, the model isn't just a piece of software. It's a suspect they're interrogating. Every single question they ask it, every answer they get back, is one more clue that could help them unlock the system's deepest secrets. Their playbook is incredibly methodical, broken down into 4 key phases. First up is reconnaissance. That's basically casing the joint, mapping out every single way you can talk to the AI. Then comes query crafting, which is the real art form of designing tricky questions to get the model to slip up. After that is statistical analysis, where they sift through all the responses looking for patterns. And finally, automated testing, where they use powerful tools to do this all at a massive scale. Now, that query crafting phase is where things get really clever. For instance, testers will use something called synthetic inputs. They'll feed the model bizarre, nonsensical data to see how it reacts when it's pushed way outside its comfort zone. This can reveal if the model has just memorized its training data. Another cool technique is incremental variation, where they might take an image and just change it pixel by pixel, just to see the exact moment the AI's decision flips. It's like a high-tech game of hot and cold. Of course, the whole point of finding these weaknesses is to fix them, right? The discoveries made by pen testers were what tell us how to build tougher, more secure AI. So let's talk about how we can actually fortify these models against these kinds of attacks. The best approach is a layered one, something called defense in depth. It starts with simple access controls, like rate limiting, which stops an attacker from just spamming the model with millions of questions. Then you have input validation to spot and block weird queries. A really big one is output protection, where you can add a little bit of random noise to the AI's answers to make them way harder to reverse engineer. And finally, regular retraining, to make sure that even if some data gets figured out, it becomes useless pretty quickly. Okay, so does this stuff actually work in the real world? Oh, yeah. There was a financial firm that was worried about its automated loan approval AI. They ran a pen test, found some problems, and put these very defenses into place. The results? They were pretty incredible. Get this. After putting these layered defenses in place, the attacker's ability to successfully extract private data from the model dropped by a massive 73%. They basically shut down the vast majority of the attack. And here's the best part. What was the trade-off for this huge security boost? The impact on the model's main job, making accurate loan predictions, was a measly 2.1%. That's a tiny, tiny performance hit for a gigantic gain in security. And that's really the crucial point of this whole story. We don't have to choose between having a powerful AI and a private one. With the right security testing and the right defenses, we can absolutely, 100%, have both. So why does a super technical topic like model inversion matter to all of us? Well, because AI is being woven into the very fabric of our society. And securing these models isn't just a tech problem, it's about securing our entire digital future. The experts in this field live by a few core principles. First, you have to know your AI's architecture inside and out to find its weak spots. Second, your testing has to be systematic and data-driven, not just random poking around. Third, you have to actually test your defenses to prove they work. And maybe the most important one, security isn't a one-and-done thing. It's a continuous, ongoing process. And this is no longer just a best practice. It is rapidly becoming a legal requirement. With huge new regulations like the EU AI Act coming online, proving that your AI is secure isn't just a good idea. It's a legal and ethical obligation you can't ignore. Which really leaves us with this one big question to think about. As AI gets deeper and deeper into our lives, and our hospitals, our banks, everywhere, the real challenge isn't just about building smarter AI. It's about building trustworthy AI. So how do we make sure that as we build this amazing future, our digital selves, our privacy, stay safe? That's the puzzle we all need to solve. Thanks for listening.